Hello, so in this video I want to just talk about how to take care of equations, linear equations, that is one-dimensional equations, that have some simplification that need to be done. So we've talked about equations with variables on one side of the equal sign and equations with variables on both sides, but what about when you have equations with variables on both sides and a bunch of simplification that's needed? Well, you guys have learned how to simplify expressions, and so I want to quickly remind you that this is just an expression right here on the left being set equal to an expression. And it's good practice to simplify both expressions before moving things around. So I'm just going to go ahead and distribute the 3 to the x and the negative 4. So 3x minus 12 plus 15. I'm going to go ahead and do some distribution on the right as well. I have to distribute this negative 1 here, this kind of implicit negative 1, minus 5 minus x, because we distribute that to both terms through multiplication. It's one negative group of 5 plus x. And over here, just to remind you, this was 3 groups of x minus 4. So just in case you're fuzzy on distribution, I'll take a little rabbit trail here. Y is 3 times x minus 4 equal to 3x minus 12. Well, this is 3 groups of x minus 4, x minus 4 plus x minus 4 plus x minus 4. I have those 3 groups. So we have 3 x's and 3 negative 4's, making 3x and negative 12. I think that's one helpful way to think about it. Let me go ahead and get this out of the way. So now that we have this, again, before I start moving things around, it's not that I have to necessarily simplify, but it just makes life a bit easier. So I'm going to go ahead and write 3x plus 3 on the left and 13x minus 5. So what I did there is I combined the negative 12 and positive 15 into 3, and I combined the 14x and the negative x into 13x. Now I've got an equation with a variable on both sides, and each expression on each side of the equal sign is already simplified. So all I'm going to do now is go about, I guess, kind of rearranging things. So I'm going to just subtract 3x from both sides. There's lots of ways we could do this. So I'm left with 3 equals 10x minus 5. Yeah, because these cancel out to 0, and this became the 10x. This 13 and negative 3 became the 10x. So now that I've got this, I'm going to go ahead and add 5 to both sides and isolate that 10x. So 10x is equal to 8. And so now I'm going to go ahead and divide by 10 to get x all the way by itself. So it appears that x is equal to 8 over 10, which is also equal to 4 over 5. Or in this case as well, we could say 8/10. So x is less than 1. About 8/10, or exactly 8/10. And we could plug it back in to check it, right? And that would mean that I'd take the 8/10, plug it back in for the value of x, and make sure it was a true statement. All right, what happens though if we have a bunch of fractions? There's something called fraction busting that I think is kind of neat that you might find handy. So I want to talk about that for a moment. Okay, so first off, this is just a normal equation. The only difference between this and the equations we've looked at already is that the coefficients are fractions, and we have a fraction number here. We could solve this just like we would solve any other equation. We would just be subtracting 13/21 from both sides and then dividing by 5/7. But there is a nice way to get rid of these fractions, and something we can do is multiply everything in the equation by the lowest common multiple of the denominators. Before I talk about why we're doing that, let's just first establish that we're even allowed to multiply an equation by a number and have it be true. So let me come up with an alternative example here, a real simple one. So 2x plus 1, let's make this equal to 7. So in this case, x has to be 3, right? Because 3 times 2 is 6, and 6 plus 1 is 7. But if I was to multiply each side of this equation by any number, let's just say 3, for example, my new equation after the distribution would be 6x plus 3 is equal to 21. Well, in this equation, before we did anything to it, we said that x had to be equal to 3. before we even multiplied. Well, guess what? X is still equal to 3. So 6 times 3 is 18, and 18 plus 3 is 21. It didn't change the value of X at all. It's because you're allowed to multiply, that's a property of equality, you're allowed to multiply both sides of an equation by the same number, and it's not going to change anything because you're just taking the same groups of each side. So it's an equivalent idea, because multiplication is just groups of, right? It's an equivalent idea of me saying, okay, I'm balanced right here with one square and one circle. That means that the circle and the square must be the same weight, right? Because they're on the same distance from the center here. So if I was to multiply, if they're the same weight, if I was to multiply both sides by 2, I would just have 2 squares is balanced with 2 circles. I guess it's really as simple as that, the concept. So if we're allowed to multiply an equation by a number, if we do both sides by that same number, then we should choose a number that's going to get rid of the fractions. In this case, I'm going to choose 21, because 21 is the lowest common multiple of 7 and 21, and those are our denominators. You'll see why we wanted that lowest common multiple in a moment. And let me finish the parentheses here. So times 21. Okay. The reason we wanted the lowest common multiple of our two denominators, in this particular example of 7 and 21, is because we want a number that all of our denominators will fit into evenly so that we can end up with whole number coefficients. For example, when I distribute this 21 to this first term here, that's 21 times 5 over 7. And when you multiply fractions, we know we can cross simplify before we do that. There's 1 7 in the 7 and 3 7s up here. So that's equal to 15. So I know this first term here, oops, I'm going to run out of room here. This first term must be 15x. And then when I multiply the 21 by the 13 over 21, the 21s cancel, and I'm just left with 13. So plus 13 equals 210. So now I've got a pretty nice equation that's very easily solved, and there's no fractions. So pretty awesome. And from here, I think you guys know how to solve equations with one variable on one side. We've already talked about it. So let me do another example where I'm using a whole number. I'm going to multiply everything in the equation by a whole number just to get rid of the fractions. And I won't bother finishing the equation because we've already done many examples that look like this. So again, a lot of people will refer to this as fraction busting. That is, you're getting rid of the fractions using the property, the equality property of multiplication. And I obviously can't write busting. I don't know why I did that. Fraction busting. There we go. So let's come up with another example. What if I had 2/3 x minus 4/5 equals 7 tenths. Okay, so we've got a lot of fraction stuff going on here. We might as well bust out the fractions using the method we've been discussing. So I would look for a number that 3, 5, and 10 are going to fit into evenly. And it doesn't have to be the lowest common multiple, but when it is the lowest common multiple, your coefficients are going to be lower, which is nice. So 3, 5, and 10, what are multiples of those, and what would be the common one? I'm thinking 30. Can't think of anything that would be lower than that. Yeah, okay, so we'll multiply everything, or rather both sides, by 30. Okay, and when we do the distribution over here, we're going to get 20x. And when I do it right here, I'm going to get 24. And on the right-hand side, we're going to get 21. And I want to talk about why I'm able to do that in my head. It's because this is my thought process. When I'm multiplying a whole number by a fraction, I first think, okay, how many times does the denominator fit into this whole number? Well, 10 times. Okay, well, what's 10 times 2? 20. How many times does 5 fit into 30? Well, 6 times. Okay, what's 6 times -4? -24. Why am I able to think that way? Well, let me get this out of the way for a moment. I'll make it larger here in a moment. Because when I do 30 over 1 times 2/3, I know that I'm going to be simplifying, in other words, dividing both sides by the common number of 3. So now I have 10 times 2 over 1, or 20. When I do the 30 over 1 times the 4/5. I know I'm going to be cross-simplifying and saying there's 1 5 here and 6 5s here, so 6 times 4 over 1, or 24. So it's really handy to kind of have that trick and be able to do it in your mind, because then it just saves you a lot of time and you never have to really worry too much about dealing with fractional coefficients in your equations, which is really nice. Let's see if I can get rid of this. Okay. So from here, I will go ahead and finish this one out because it's my last example. I'm going to add 24 to both sides. 45 and 20x. So therefore, x must equal 45 over 20 because I divide both sides by 20, which is equivalent to 9 over 4, I believe, which would be 2 1/4. So we could say that x is equal to 2.25 or 2 1/4. All right, guys, thanks for watching, and I hope this was helpful.